Ben is from UIT, and just to give you a short update again of his background. In 2008, he completed his bachelor's in microbiology at Abia State University in Nigeria. 13 years later, he obtained his master's thesis in marine biotechnology from UIT, the Arctic University of Norway, as part of the AquaVitae project. And in his thesis, he compared the biochemical composition and bioactivity of the European abalone, the Haliotis, tuberculata, coccinea, which were cultured on 3 different diets. And the results, I would say, were especially promising for the abalone diet consisting of macroalgae produced from IMTA. But I will let Ben tell you more about this. But before you start presenting, Ben, actually, we want to get to know you a little bit better. So first of all, congrats on your master's that you handed in this year. And if you don't mind me asking, it was 13 years between bachelor's and master's. What did you do in those 13 years? Yeah.
Thank you, Emil. But first of all, I like to apologize for the little glitch. So like Emil said, sometimes this kind of things happen. So like, welcome everyone. So to answer your question, Emil, I got my bachelor's in 2008 in microbiology. And in 2009, I started working as a microbiologist in a hospital. And I did that for like 6 years. It was basically culturing specimens to check out for bacteria in hospital settings.
Which is a very important job, especially today.
Yeah, I must agree. Yeah, definitely. So I have worked as a microbiologist
So
from 2009 to 2015.
Cool.
Yeah, and I left that briefly to work with my family in your business, because we have a stockfish business.
A stockfish, that's could you just explain what stockfish is to someone who wouldn't know?
Yeah, so stockfish is like a tradition in Norway. They get caught and then they hang it on racks, during the winter, and then let it to be dried by the cold, So this is has been like maybe from the Vikings age, So I think during the 1950s or 1960s, when we had a civil war in Nigeria, and the Norwegians, they introduced this stockfish heads, as aid to, children that were suffering from a lack of protein. So after the war, people liked the taste of stockfish. So the market grew from there, and there was huge demand for stockfish. So a lot of people, went into this business. So yeah, basically stockfish is like dried cods.
It's super rich in protein because all the liquid is gone. So it's like what 83% protein or something like that.
Yeah.
Very protein rich. Yeah, but it's very cool that you were in that, and now you're obviously in Norway, and you did your master's in marine biotechnology. But how did you go from microbiology then to marine biotechnology?
Yeah, it's interesting because even when I was in microbiology, I was always interested in in business, and not just like business literally, but how you can make products with things. And I thought that biotechnology generally give you the tools to make novel products from what you find in the environment. So yeah, I got interested in biotechnology, to be precise. But then when I discovered the program at UIT, Marine Biotechnology, I felt like it was like tailor-made for me. It's marine and it's biotechnology, and it's also in Norway. So it was like it ticked all the boxes for me, and I found myself here.
It's very cool. So you moved to the home of the stockfish, and now you're working with low trophic aquaculture and macroalgae. And abalone.
Yeah.
It's really nice to get to know you and to know your story. Of course, I always find it fascinating to to hear about other people's careers. And I mean, and I gotta say, you've had quite a career already. And now you're just, it's going just one way, and that's up, isn't it?
Yeah, of course.
That's great.
Yeah.
So I don't want to take up more of your time with questions. We really look forward to hearing your talk. So it's already up. So I will just turn off my camera and let you have the word. Welcome, Ben, and go ahead, please.
Yes. Thank you, Emil. Once again, I'll say hello to everyone that has joined this live webinar, and also to those that will watch this video later on YouTube. Like you must have known now, my name is Uchenna Ben Opara. And for over 1 year, from 2019 to 2021, I have studied the biochemical composition and bioactivity of abalone. First, the South African abalone, Haliotis midday, and then the European abalone, Haliotis tuberculata coccinea. A large part of that work was focused towards completing my master's thesis, which was delivered in March of this year. This thesis is now available in Munich. Munich is the Arctic University of Norway's research repository. And to access that, you go to munich.uit.no.
I'll put a link in the description for them, Ben. Thanks.
Yes. And currently, my work as a research assistant at the university where I completed my master's, it has given me the privilege to stay in touch with the latest researches and developments, not just in abalone aquaculture, but also aquaculture of low trophic species, which is the focus of the AquaVitae project. So in the next 15 minutes, hopefully less, I'm going to present macroalgae from IMTA. Is it a substitute diet for abalone aquaculture? And before I go into the presentation, I want you to keep 3 things in mind. Sorry.
It did not work. There you go.
Yeah. So macroalgae diets produce higher fat and protein content in the abalone that was studied. And the number 2 thing you have to keep in mind is macroalgae diet resulted in high amounts of essential amino acids. And finally, the artificial diets contain more total omega-3 unsaturated fatty acids. So we go into the presentation. So first, I'll give you a background around the topic, after which I'll give an introduction to abalone and abalone aquaculture. And then the purpose of the research will be is encapsulated in the research questions. So afterwards, I will give you an outline of the methods that was used in the study, and then I'll conclude this presentation by showing you the results that were obtained in this research. So a brief background. Aquaculture is a fast-growing sector. Actually, it is the fastest-growing food production sector with an estimated 7% growth rate per annum. And when you put that into perspective, you see that it means a lot of things to different stakeholders. Obviously, it means more food is available for human consumption. However, it also means that more food inputs is needed to produce the fish that we love to consume. And presently, like wild fishes that are used in the production of fish meal and fish oil, they have been overfished. So fish meal and fish oil are derived from these wild fishes and are used to feed the fishes that we consume, like salmon and etc. So overfishing of these wild fishes is a problem because they are at the risk of collapsing, that is, their stock in the wild could collapse, if we continue overfishing without effective strategy. So we have been looking for solutions to this problem of overfishing, and IMTA, which stands for Integrated Multi-Trophic Aquaculture, has been identified as a solution. So simply put, IMTA is when you cultivate 2 or more aquaculture species that belong to 2 different trophic levels. So when we say different trophic levels, it means that these 2 species, they cannot compete for the same food. So when you cultivate them together in such a way that the food waste from the fed species becomes food and fertilizer for the species that is cultivated alongside it, then that is IMTA. So an example would be that, for example, you have a salmon farm, and then you cultivate something like mussel, which is like a filter feeder next to your salmon cage, so that the waste from the feeding of the salmon, the organic waste from the feeding of the salmon seeps down in the water and it's absorbed by these mussels, which are filter feeders. An iteration of this system could also be to like cultivate macroalgae alongside the mussel and the salmon, so that the inorganic waste from the feeding operation of the salmon is also absorbed by this macroalgae. So at the end of the day, the benefit you get is, instead of harvesting one crop, which is your normal salmon, then you can harvest microalgae alongside the salmon and the mussels. So that makes economic sense. But also, this is good ecologically, because the macroalgae helps to capture some carbon from the water. So IMTA is not new in Asia, especially in China. So there is evidence that this may have been practiced for like over a millennia in China. However, to the rest of the world, it's a new concept, and we are now starting to like document the benefits of this system. So recently in Europe, this has become a big thing. We are studying IMTA, and there's need for documentation of quantitative data, for relevant stakeholders to make decisions about IMTA. So, and that is one of the relevance of my research. So when we talk about documentation of relevant data, most of us will say, yeah, we need scientific data. But it's also important to know that there are economic and social aspects to IMTA, and such data must also be documented. So I quickly go to the introduction. So Haliotis species is the only genus in the family Haliotidae, and Abalone belongs to this Haliotis. So actually, you can find abalone in all marine waters across the world, both in temperate and tropic waters. So it's a luxury seafood, maybe mostly in Asia, in Korea and Japan and China. They consume this during ceremonies and also at high-end restaurants. So abalone is valuable, not just because it's a luxury food, but also the shells, which are strikingly beautiful. They are harvested by people and sold. So because of the value attached to abalone, this organism has exhibited higher risk of stock collapse more than any other marine organism. So, and also in Europe, people are becoming interested in abalone, and consequently, the European abalone, which is tuberculata coccinea, has been identified as a species that can be developed commercially. Of course, it's already developed commercially, and it's native to the Canary Islands. So abalone diet. Abalone in the wild, they feed on macroalgae, but due to the fact that 95% of abalone that is consumed today is produced in aquaculture, more and more people, use artificial diets in abalone production, and it makes sense because these artificial diets are easily available compared to macroalgae, which is not that easily accessible. And also there is this belief that to make abalone grow faster, you need to feed them, with a loaded protein and lipids, which they believe is in the artificial diet. So macroalgae, naturally in the wild, you could expect it to have a fat content of maybe 1% and a protein content of maybe 9%. But when you produce it in IMTA scenario, where they get nutrient-rich waters, then you can expect a protein percentage of even 34%. So like in the research, I set out to understand a few things, and some of those things are listed in the research questions that you see on your screen now. So quickly, I'll just read it. Are there differences in the biochemical composition of tuberculata coccinea fed with IMTA macroalgae diet, an artificial diet, or a mixed diet of the IMTA and artificial diet? Then does any of these diets produce abalone with a more beneficial composition of fatty acids and amino acids? So once I articulated these questions, then I set some objectives to help me answer those questions. So quickly, to determine fat content after fat extraction. Also to determine fatty acid composition after breaking down the fats into their component fatty acids. Fatty acids, of course, are the building block of fats. So when you break them down to fatty acids, it helps you to see, the proportion of maybe so-called healthy fats and not so healthy fats that you have in the abalone. Then the protein content was also analyzed by breaking them down to amino acid and then summing the amino acids. So quickly, the methods. So the sample, we had pulled abalone from treatment from the different treatments that we have just listed. So, and they were juvenile abalone, and juvenile abalone is like abalone that's like 6 months old. So these were like from juvenile abalone, and then 2 or 3 replicates depending on the experiments were used, and all the experiments were done twice. So in the quantitative analysis, as we said earlier, fat, protein, fatty acid, and amino acid were tested. And simple statistics were used, means and standard deviations, the student t-test, and then significance level was set to 5%. So here we go, the results. So first of all, the fats, macroalgae, the abalone that were fed macroalgae, surprisingly, had higher fat content than the one that were fed the artificial diets. You would expect the opposite of this, because normally the artificial diets, they have higher fat content than the that you will find in macroalgae. Same thing with the protein. There was higher protein content in the abalone that was fed macroalgae than in the one fed the artificial diets. And this could be that maybe the young abalone, they were able to digest the fats and the proteins that were in the macroalgae better than the ones that were in the artificial diets. And then the hybrid diet was like a gradient. It was between the artificial diet and the algae diet. So you could see a gradient increase. Then the fatty acid composition. I know this is like a lot of figures for you to assimilate or make sense of, but I just put it up here so that if you're watching this video, later, and maybe some of these things make sense to you, then you can always go back. Alternatively, you can go to Munin and find the full reports. But in this slide, I'm trying to highlight that in the artificial diet, we had total saturated fatty acids of 41% and a little less in the macroalgae diet. While in the polyunsaturated fatty acids, we had 24% in the artificial diet and then 29% in the macroalgae diet. And like we all know, like the polyunsaturated fatty acids are healthier than the saturated fatty acids. So this might make sense to a lot of people. And the omega-3s, you know, the omega-3s are also polyunsaturated fatty acids, you know, but they are quite important. These essential fatty acids the human body cannot produce, so we must get them from our diet. You know, so when you look at the results here for the EPA, at the artificial diet and the macroalgae diet had the same content of EPA, but then when it comes to DPA and DHA, then the artificial diet had less DPA than the IMTA algae, but for DHA it had higher amounts of this fatty acid, you know. So, but when you take the total of this omega-3s, then the artificial diet had a slight greater number than the IMTA algae. But then we ask ourselves, does this really make much difference? Because abalone is a luxury seafood, and you know it's consumed not daily for the needs of these essential fatty acids. You know, so does it warrant us to continue using our fish meal? You know, even at the cost of the environment for a luxury seafood? Then the N6 N3 ratio, like this simply is a ratio of omega-6 to omega-3, and normally you want this to be low. So in a normal healthy diet, when the N6 to N3 ratio is like 4:1, then it's good. If it's 1, it's even better. So for all samples, the N6 to N3 ratio are very good, you know. But the artificial diet is slightly better than the IMTA algae. Yep. So in the amino acid composition, when you look at the percentage of the amino acids in all samples, there are not much differences in the percentage composition, which means like no matter the diet, they still had the same proportion of these amino acids. So, but then when it comes to the amount, the absolute amounts of these amino acids, then it's a different story. You know, when you look at the IMTA and the hybrid and the artificial, you see a gradient decrease, or if you put it the other way around, if you look at the artificial diet and the hybrid and IMTA, there's a gradient increase. So the amount of the essential amino acids varied directly with the amount of macroalgae that was in the diet of this juvenile abalone. You know, and these essential amino acids are simply amino acids that the human body cannot produce, so we must get them from our diet. So that's it. So to summarize these results, yes, the macroalgae diet produced higher fat and protein content in abalone. And also the macroalgae diet resulted in higher amounts of essential amino acids. But however, the artificial diet contained more total omega-3s than the macroalgae diet. And we saw that it was due to a high amount of THA, but the EPA and DPA were not greater than in the macroalgae diet. So putting this in perspective, what can we conclude from this? Yes, macroalgae from IMTA can be a substitute diet for growing juvenile abalone. We cannot say this for the whole of abalone because juvenile abalones, we are the ones that are tested in these experiments. But also there are other studies that support that macroalgae diet, can be used as a substitute in abalone aquaculture. So more research efforts definitely is needed in this. One way of looking at it is that yes, macroalgae is good for abalone aquaculture, but is it easy to assess macroalgae? Macroalgae is not grown in all places yet, and to harvest them is very expensive, like compared to the artificial diets, which are very easily accessible. So we need more research efforts to ensure that not just macroalgae, but IMTA macroalgae is used increasingly in abalone aquaculture. And I want to thank you for listening to my presentation. Thank you.
Thanks, Ben. Thanks a lot for this presentation. It was excellent. Now, if anyone has any questions, feel free to write them in the chat or raise your hand, as I mentioned. I actually have a question for you, Ben, if you don't mind.
Okay.
Yeah. So, well, first of all, do you foresee macroalgae-fed abalone from IMTA being scalable, and do you know if anyone is today producing abalone in this way today?
Yeah, I think most of the work about IMTA abalone has always been at research scale. I do not know presently if anyone is using macroalgae from IMTA in abalone aquaculture.
Okay, well, if anyone in the audience knows, then feel free to share as well, of course. And
Yeah, sure.
when it comes to, I know you probably haven't looked at this, but when it comes to growth rate, do you know anything about which type of diet is better for abalone, like, or what the literature says, etc.? Because I imagine that for farmers, growth rate usually, or always at least, or always or usually at least, comes first.
Yeah, but I came across this study also on the AquaVitae project, and I think these guys are from Spain. They studied the growth rates of abalone from IMTA and those that were fed Mari feed. Mari feed is another commercial feed, and they saw that the growth rates in the macroalgae in the mixed diet actually was highest than in the artificial diet. So yes, but I think maybe more research is needed in this,
Yep. No, fair enough. Sorry, I was interrupted in my office just now. Right. So if anyone has any questions, then feel free to put your hand up, or if you're writing something in the chat, you can press enter and send it away. But I want to thank you, Ben, for taking the time at least to join us today. Technical issues always occur, but I'm happy that the audience stayed in the meeting as well. I can see that everyone is still here, and thankful that so many took the time to join us right before the holidays, and to listen to what is our last webinar of this year. For AquaVitae, of course, we're going to continue with this webinar series next year. It's not going to be me hosting them, as I'm leaving the project and Nofima, but we will have someone replacing me, and he or she will obviously take care of the rest. So yeah, thanks again for being here, Ben, and thanks for everyone for joining us from your homes all over the world. Thanks.
Thank you, Emil.
Bye, everyone. And Merry Christmas and Happy Holidays.